This is a Centennial Academy video based off of Lewis dot diagrams. First off, you need to know the basic steps in order to build a Lewis dot diagram. Step 1, determine total valence electrons. Step 2, determine the central atom and arrange peripherals according to bonding capacity. Step 3, bond each peripheral atom to the central atom. Step 4, arrange leftover electrons around peripheral atoms. And finally, move electrons so the central atom has 8 electrons, a full octet. The first Lewis dot diagram example will be nitrogen triiodide. And the first step is to determine the total number of valence electrons. And on the periodic table, if you check, nitrogen has 5 and iodine has 7. But in nitrogen triiodide, there are 3 iodines, and 7 times 3 is 21. And you have to add in the 5 nitrogens, so that's a total of 26 valence electrons. The second step is to determine the central atom and arrange peripherals according to bonding capacity. So in this case, nitrogen would be the central atom because it has the highest bonding capacity. Fluorine has the highest bonding capacity because of its number of electrons, and the further down you go or the further to the left you go, the less reactive it is. The third step is to bond each peripheral atom to the central atom. In each bond there are 2 Lewis dots. The fourth step is to arrange leftover electrons around the peripheral atoms. So right now there are a total of 24 out of 26 of the electrons, and the last step is to move all the electrons so that the central atom has 8, a full octet. So our next example will be carbon dioxide. Carbon has a total of 4 valence electrons, oxygen has 6, but there's 2 oxygens in carbon dioxide, so that's 12, plus the 4 is a total of 16 valence electrons. In this case, carbon would be the central atom because it's a 2-to-1 ratio against oxygens. The next step is to bond each peripheral atom to the central atom. And then you fill in peripheral bonds. And that's a total of 16 electrons. However, carbon likes to be bonded 4 times and oxygen likes to be bonded twice. So you can move some of these bonds over to form double bonds with 2 lone pairs on each oxygen. The reason why the oxygens are so far apart is because electrons in valence shells repel each other such that they are as far away as possible from each other yet attached to the central atom. Our third example will be the polyatomic ion phosphate, which consists of phosphorus and oxygen. There are 5 valence electrons in phosphorus and 6 valence electrons in oxygen. But since there are 4 oxygens, that would be a total of 24 valence electrons. Since phosphate has a -3 charge, you add in 3 more electrons because you're gaining them. The next step is to determine the central atom, and in this case it would be phosphorus. And the next step is to bond each peripheral atom to the central atom, which takes up 8 electrons, and you arrange the leftover electrons around the peripheral atom. And this uses up all 32 of our valence electrons. But since there's a -3 charge, you have to put brackets around the Lewis dot diagram and add in the charge. Our fourth example will be nitrosonium ion, which consists of nitrogen and oxygen, which has a +1 charge. Nitrogen has 5 valence electrons, whereas oxygen has 6, and since there's a +1 charge, you're losing an electron. So that's a total of 10 valence electrons. Next step is to determine the central atom, but since there are only 2 atoms, in this case, there would be no central atom. Then you gotta bond each peripheral atom to the central atom. And then you arrange the leftover electrons around one of them. So there's all 10. However, that does not work because nitrogen likes to have 3 bonds since it has a total of 5 valence electrons. So you would just move 2 of those over, which would make a product looking like with a lone pair on each atom. Our last example is carbonic acid. So there's a total of 2 hydrogens, which each has 1 valence electron, 4 carbons, and 6 times 3 oxygens, which makes a total of 24 valence electrons. So in this Lewis dot diagram, carbon would be the central atom because of the ratios, oxygen would be spread throughout, and hydrogens would be on the ends, farthest away from each other. You bond each peripheral atom to the central atom. You include and fill in all the octets. And that's a total of 24 valence electrons. However, as you recall from one of the last examples, carbon likes to have a total of 4 bonds. So you just move one of those over, create a double bond, and that's the Lewis dot diagram. Our last Lewis dot diagram will be an ionic compound example. So magnesium chloride has a positive 2 charge on magnesium and a negative 1 for chlorine, which you take down and you switch them around, so it's magnesium chloride. Since there's only 1 magnesium, that would make it the central atom with the 2 chlorines surrounding it as the peripheral atoms. And you can't forget to put the 2 positive charge, and since chlorine has the negative, you include the brackets. And for ionic compounds, they always have a full valence shell. And that's the final product of our last example.